What tools detect additive manufacturing defects during printing? Imagine watching a complex 3D printer work, layer by layer, building a part. But how do we know if something is going wrong before it's too late? That's where defect detection tools come into play. During additive manufacturing, or 3D printing, a lot can happen that causes flaws like pores, cracks, or incomplete fusion. Detecting these issues in real time is key to making reliable parts. Let's explore the tools that make this possible. First up are optical and thermal cameras. Visual cameras keep an eye on the melt pool and powder bed, watching for shape changes or temperature shifts. Infrared cameras measure heat patterns, which can reveal irregularities in the melting process. High-speed cameras capture tiny details at thousands of frames per second, helping spot issues as they happen. These cameras are like the eyes of the process, catching problems early. Next are advanced X-ray imaging systems. These tools use high-energy X-rays to look beneath the surface of a part while it's still being made. They can detect tiny pores or voids inside the metal that are invisible to surface sensors. This real-time imaging helps identify subsurface defects like keyhole pores, which can weaken a part if left unnoticed. These systems are highly precise and can catch flaws that traditional surface checks miss. Acoustic and vibration sensors add another layer of monitoring. During printing, the machine emits sounds and vibrations. Changes in these signals can indicate cracks forming or layers separating. By listening to these sounds, operators can detect anomalies that might not be visible but could lead to failure later on. Laser profilometers scan the surface layer by layer. They measure the topography and detect deviations from the intended shape. If a layer is uneven or missing, the profilometer spots it immediately, allowing corrections before the build continues. Spectroscopic sensors analyze the light emitted from the melt pool. They check the chemical composition in real time, ensuring the right materials are melting correctly. Irregularities in the spectrum can signal contamination or improper fusion, which could cause defects. Process parameter sensors keep track of laser power, scanning speed, oxygen levels, and mirror positions. If any of these drift from their set values, it can lead to defects. Monitoring these parameters helps keep the process stable and consistent. Artificial intelligence and machine learning software are transforming defect detection. These algorithms analyze the data from all sensors, looking for patterns that indicate potential flaws. They can predict when a defect might occur and suggest adjustments to prevent it, making the process smarter and more reliable. All these tools work together to give a comprehensive picture of what's happening during printing. They help identify problems early, so manufacturers can fix issues before the part is finished. This is especially important for critical parts in aerospace, medical devices, and automotive industries, where failure isn't an option. Using real-time detection reduces waste, lowers costs, and boosts confidence in additive manufacturing. In short, detecting additive manufacturing defects during printing involves high-tech cameras, X-ray imaging, acoustic sensors, surface scanners, chemical analyzers, process monitors, and intelligent software. These tools work in harmony to catch issues as they happen, ensuring the final product is strong, reliable, and ready for use.